Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and today we're going to be looking at a range of different techniques using matrices for our specialist students in grade 11 and 12. We're going to look at the transpose, inverse and singular matrix. And in this particular video you'll find out what they are with some worked examples, and then we'll move on to doing that with technology on the Casio CG50. Okay, so if you are finding these videos helpful, if there's something you saw today that really helped you out, why not like the video, subscribe to the channel and hit your notifications button. Even better, tell a friend or follow us on Facebook and Instagram. Best way to find out what new videos are coming and get some facts, tips, competitions and the like. Okay, let's get straight into it and talk about those transpose matrices. So in our previous video on finding the determinant, we found out that the determinant of a 2x2 matrix was given by the formula AD take away BC, and that's on your formula sheet. Now you would recall from junior mathematics that the word transpose means to rearrange. So what we're technically doing here is rearranging a matrix in a different kind. We're actually swapping columns with rows, and it's going to look a little bit like this. So we've got that first row becomes our first column, second row becomes our second column. So that's pretty straightforward to do. Let's see what that looks like with the way we notate that. So we've got our original matrix. If it's notated as matrix A, we've got A with a little superscript. It's not really a power, it's a superscript of T, and that says that that's the transpose of the original matrix. So for a square matrix, which is what we're mainly doing here with our senior mathematics, is we are flipping our elements over that leading diagonal, which runs from top left to bottom right. So it's going to look something like this. So A, E and I are going to stay in the exact same positions. They are not going to move, but everything else is. G and C are going to take a switcheroo. D and H are going to swap to that top right hand section, and B and F are going to swap to the bottom left hand section. Now if you have a look at that, what we've effectively done is taken row A, B, C, and it's now become column A, B, C. And then if we took row D, E, F, it becomes that middle column, and the bottom row becomes the third column. Okay, now the reason why we have these different arrangements with the transpose matrix, something to be aware of, is that the determinant of 1 being A is the same as the determinant of the transpose of A. So that's something very important to be aware of. So determinant of A is the same as determinant of A transposed. Okay, let's move on now and talk about the inverse of a 2x2 matrix. So you're expected to be able to do this algebraically. It's also good to be able to check that on your calculator as well. So you will recall from your index laws from grade 9 that when we raise something to the power of 1, we're calling that we're basically finding the inverse of that. It's the same as taking the number 1 and dividing it by A. You would also recall that when we take that and we multiply that by the inverse, we get the number 1. So if you think about that, the inverse of 3 is a third, and if we find a third of 3, it's 1, and that's going to work for any whole number or any fraction in that fact. Okay, so we call 1A the multiplicative inverse of A, and when we multiply them together, we get the number 1. And so when we have a matrix A and we want to find its multiplicative inverse, it's shown as A to the power of minus 1. And we find that inverse by doing a fair bit of tricky maths here. We're going to swap that leading diagonal around, make all of the other elements negative. So that's going to look a little bit like this. Our original matrix A was A, B, C, D, and we're going to switch A and D to the opposite sides, and then C and B stay in the same spots, but they become negative. And then we take what we've transposed around and we're going to multiply that by the inverse of the determinant of A, which is 1 over determinant A. Okay, so let's have a look at what that looks like as a big chunky formula. It's on your QCAA formula sheet, so you don't need to memorize that, but there is a fair bit of work involved in that. So let's do that now in a moment with a worked example. Now, something to be aware of before we jump into that worked example, that the determinant of A can't be 0 if we want to find an inverse. So if you've got a 0 in both rows of your matrix, you're not going to get a possible inverse at all. And there are other situations as well where you're going to end up with a determinant of 0 and you're not going to be able to find the inverse. So something else to be aware of is that with matrices, we can't divide them, we have to multiply them. So this is where it becomes quite interesting. A square matrix, when we multiply that by its multiplicative inverse, what we end up with is something called an identity matrix. We've talked about that in previous videos, and we call that result I. Now that looks like a number 1, it's actually the letter I. So in other words, A multiplied by its inverse is equal to an identity matrix. Now you would recall that an identity matrix looks like this. Its leading diagonal is all 1s and all the other values in the matrix are 0s. So we're going to verify that actually happens, that we end up with an identity matrix by multiplying A by its inverse. So firstly we've got to find the determinant of A by using our determinant formula, AD minus BC. So we got 1 by 4, take away 2 by 3 gives us 4 take away 6, which is negative 2. So now we've found the determinant. Thank goodness it's not 0, otherwise we can't find the inverse. So now we need to apply the formula. We're going to firstly rearrange our original matrix. We're going to swap A and D around, and we're going to make our other variables, B and C, negative numbers. And then we're going to now find the inverse using our formula. So we multiply everything in the matrix by -1/2. So that's very important as well, that you're working with your whole numbers and negative numbers and fractions, that you're working that out using the knowledge that you have from primary school about working with fractions and working with negative numbers. And it's basically just scalar multiplication at this stage. Okay, so now we're going to multiply A by its inverse. So we've got A and its inverse that we just worked out using the formula, and we're going to work out what the new matrix is, A, B, C, D, because it's a 2 by 2 multiplied by a 2 by 2, so we're going to end up with a 2 by 2. Okay, so we're going to basically use our run and dive process. So we multiply 1 by -2 and we add to that 2 by 1.5 and we get the number 1. I am moving through this quite quickly. You may wish to pause and see if you can practice your product multiplication here and get the right answers. Okay, so that was row 1 times column 1. Let's do row 1 times column 2. 1 times 1 minus 2 times 1/2 gives us 0. And then we've got 3 times -2, which is -6. So we're multiplying row 2 now by column 1. And then we're going to add to that 4 times 1.5, which is 6. So 6 take away 6 gives us nothing again. And then our last number is, we're going to do row 2 times column 2. So 3 times 1 is 3. And then 4 times -1/2 gives us -2. So 3 take away 2 gives us 1. Hence, we've found an identity matrix. Our leading diagonals is all 1s and the rest is 0. So we've just proved that anything multiplied by its inverse gives us an identity matrix. Let's talk a little bit more about that whole concept that we went back to about a determinant not being able to be a 0 because it's on the denominator. So we've got the formula there for the inverse matrix, and we notice here that if the determinant of A was 0, we're going to end up with an undefined result. We're not going to be able to find the inverse. So when we have the determinant of a matrix being set for 0, we call this a singular matrix. We've already mentioned that if you've got zeros in both rows of your matrix, you're not going to have an inverse possible. So a situation like that is an inverse matrix. Sorry, is a singular matrix. Any situation where the absolute value of AD is equal to the absolute value of BC, because one gets subtracted from the other, is also going to result in a singular matrix. So in situations like that, we cannot find the inverse. So let's prove that a matrix is singular by using our determinant formula. First of all, we've got to find the determinant, AD minus BC. So -3 times -4. Then we're going to take away 6 times 2. So I've got 12, take away 12. And I've got the determinant of A is 0. Therefore, it's a singular matrix. Now let's do this using some technology. We're going to jump onto the Casio CG50 and find the inverse of the matrix given. So we're going to find the inverse of this matrix, 1, 2, 3, 8, 9, 4, 7, 6, 5. So the first thing we need to do on our CG50 is get ourselves onto this screen where we're going to enter our first matrix. And if we press execute, it'll ask us to put in the dimensions of our matrix. It's a 3 by 3. So then we do that and press execute. And it's going to give us a blank matrix to work with. So now we need to enter our values. So let's enter the values of all of our different numbers and elements in that matrix. And now we have our whole matrix set up here. So now we want to exit out of this menu. So we press exit and we come back to a blank screen again. Now you would recall that we're going to actually choose option and then mat VCT, which is where we went to find the determinant. But this time we're not finding the determinant, we're finding the inverse. So I'm actually going to choose mat for matrix again and tell it that I'm looking at matrix A. So I'm actually going to choose my alpha button and then A. And then I'm going to raise that using my power button to the power of -1 and press execute. And voila, I have the inverse matrix. Well, let's have a quick look at what's coming up next. We've got some videos coming up on matrix equations. We're going to do some transformation with matrices, and we're going to continue unpacking paper 2 from Queensland's Complex General Maths exam from 2020. Once again, thank you for joining me here at McClutchy Maths. Do follow us on Facebook or Instagram where you can privately message us, or otherwise you can send a message through mcclutchymaths@yahoo.com. Well, you've been watching McClutchy Maths today. I'm Natalie McClutchy. Have a wonderful day.